All right, guys, this chapter, we're going to start talking about quadratics. Quadratics is x squared. All right, it's really important for you guys to pay attention, follow along, write down the stuff that I'm talking about, okay? A quadratic function is x squared. X to the first power makes a line. X to the second power is a quadratic. So everybody remember the quadratic formula. Okay, we're going to need to know that. Our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so where do you get those lovely letters from? A is the number in front of x squared, b is the number in front of x, and c is your constant. In this whole chapter, we're going to be talking about polynomial functions of higher degree. So it's going to be higher than squared. It's going to be cubed to the fifth power, the sixth power, whatever, but we'll talk about that later. A quadratic function. Okay, this is a quadratic function right here. We're going to say this is in standard form. I'm going to talk to you about the different vocabulary because WebAssign does things a little differently. So I'm going to show you some examples, but when Ms. Thompson and I test you, this is our quadratic function in standard form. Another form that they're going to talk about is vertex form. So you're going to need to know these two forms. Vertex form looks like this. F of x equals a times x minus h squared plus k. You guys are like, where are all those letters, those weird letters and stuff coming from? Well, a is the same as a in standard form. It's the number in front of x squared. Your h and your k are what's called the vertex. And everything we talk about today is going to be centered around the vertex. It's the x value and the y value. We're going to talk more about it in a minute. Just want you guys to write it down. But you need to know both of those forms, standard form and vertex form. We're going to talk about how you go from one to the other, what it means, that sort of a thing. All right, talking about a parabola. What is the shape of a parabola? It's a U. All right, what kind of a parabola is this? Positive. Okay, so this is a positive x squared. And what is this one? It's a negative x squared, okay? So just by looking at the equation in standard form, you can tell if your parabola is going upward or if it's going downward. If x squared is positive, it's a positive up parabola. If it's negative, it's down. So in both cases, there is a vertex. Okay, in both cases, there's a vertex. It's either the highest point or the lowest point. In a positive parabola, your vertex here, is that a minimum or a maximum? It's a minimum. It's the lowest point. So a positive parabola is going to have a minimum. And the way that you would state that, it's the minimum at the y part of the vertex. So what is this one right here? Maximum. Good. And how do you read that? The y part of the vertex. Because think about this, guys. If you're talking about minimum and maximum, high and low, what axis is that on? The x or the y? The y. Okay, good. All right. Now we're going to talk about something called the AOS, the axis of symmetry. Think about what that word means. What is the axis of symmetry? It's a vertical line that does what? Cuts the parabola in half, okay? So your axis of symmetry is always going to be a vertical line that cuts the parabola in half. Vertical lines go through what axis? The x. So your axis of symmetry is going to be at the x part of your vertex. This is going to make a little more sense in a minute when we go through this. We're also going to talk about domain and range. Domain and range. All right, domain, x values, range is y. For the parabolas that we're talking about, our up and down parabolas, your domain is always going to be the exact same thing every single time. It's going to be negative infinity to positive infinity. Because what are the arrows doing? What do the arrows at the end tell you that the parabola is doing? Never stops. It's going to continually get wider, whether it's going up or down. Your range is going to be based upon y part of the vertex. Think about range. Range is from where to where? Low to high. So it makes sense that it's based upon the y. There's only two options for range. Okay, so let's talk about this for a second. Do you guys agree with me that this is negative infinity down here? This is positive infinity up here. Yeah? So if I have a positive parabola, where is my range? It's either going to be from negative infinity to this part of the vertex, or from that part of the vertex to positive infinity. What values are on this graph? From the vertex to where? Infinity, up. If you have a negative parabola, okay, if my parabola is negative, what's my range going to be? From negative infinity to the vertex. Those are the only two options when you guys have range. It's either, if it's a negative parabola, it's negative infinity to the vertex. If it's a positive, it's vertex to infinity. You'll never have anything else. It's only those two options. What is your domain for every single parabola that we're going to talk about this chapter? Negative infinity and positive infinity. Everything else is based pretty much on the vertex. We're going to talk about how to find that, and I'm going to go through things, and then tomorrow we're just going to practice. Everything I talked about today, we're going to practice tomorrow. But this is a good slide to have, kind of know what's going on. All right. It's pretty much everything I just said. Now, notice how this says standard form. This is really what kind of a form? Vertex. This is vertex form, because here is your vertex, the H and the K. And again, I'll explain more of this. It's like when you're given a point and a slope. Just kind of plug it in. But we'll talk more about that in a minute. Hang on. All right, so describe the parts of the graph. Tomorrow, and on your quiz, whenever we have it, you're going to have to do all of this stuff. You're going to have to talk about all these characteristics. Domain, range, vertex, max and min, axis of symmetry, x-intercept, and y-intercept. Now, a lot of these things you can answer completely or get an idea of just by looking at the graph. All right, first of all, this is a quadratic function, correct? How do you know it's quadratic? What's the highest exponent? 2. Okay, so you know it's quadratic. So what's the domain for every single quadratic we're going to talk about this chapter? Negative infinity to positive infinity. If you don't get anything right, please get that part right. Now, what kind of a parabola is this? Positive or negative? Positive. So draw yourself a little picture. Okay, this is a happy parabola. It's facing what direction? Up. It's facing upwards. So think about this point right here. This vertex, is it a maximum or a minimum? It's a minimum. It's going to be a minimum. And it's going to be at the y part of the vertex. We don't know what it is yet, but we'll find it. My axis of symmetry is going to be this vertical line that cuts this in half, correct? What part of the vertex do we put that at? X equals, good. Let's think about our range. Does my range go from negative infinity to the vertex, or from the vertex to positive infinity? Vertex to positive infinity. So it's going to be from whatever the y part is of the vertex to positive infinity. And it's always going to include that point. So use a bracket. Now, there's one more thing. We can just stare at this and you can tell me what it is. Can I look at this and tell myself the y-intercept or the x-intercept? How do you know the y-intercept? It's the constant, right? If I plug in 0 for x, then my y-intercept is just 7. So you would write it as 0 for x, 7 for y. So you guys have a pretty good idea of what this parabola looks like. You know it's going upwards. You know it's going to cross the graph at 0, 7. You know it has a minimum value, all that stuff. So let's find the vertex. Does anybody have any idea? Anybody remember if you talked about this in Algebra 2 or Algebra 2 Honors? What the little tiny formula is to find the x part of the vertex? X equals negative b over 2a. Why are we talking about A's and B's? Where do we get that from? Okay, what's the A value here? 2. What's the B value? 8. Can we evaluate this? For sure. Negative 8 divided by 2 times 2. Negative 8 divided by 4 is negative 2. So what is the x part of my vertex? Negative 2. What is the axis of symmetry? Negative 2. Good. Okay, so I know the x value, and I have an equation. How can I find a y value? You plug the x in. What is f of x the same thing saying? Y. So say y equals 2 times negative 2 squared plus 8 times negative 2 plus 7. This is where you guys will make mistakes, because you'll multiply wrong or something. What's negative 2 squared? 4, and 4 times 2 is 8. So 8, what's 8 times negative 2? Good. So left to right, what's 8 minus 16? And negative 8 plus 7 is negative 1. So what is the y part of my vertex? Negative 1. What is the minimum value at? Negative 1. What is my range? Negative 1 to infinity. We have answered every single one of these characteristic questions literally by looking at the equation and then doing that tiny little computation to find the vertex. You also know how to find the x-intercepts, guys. This is probably the most computation you're going to have to do on any of these problems, because how did you find the y-intercept? You plugged in 0 for x, right? So how do you find the x-intercept? You plug in 0 for y. So it's 2x squared plus 8x plus 7 equals 0. And what do? You hope and pray that it factors. 2 times 7 is 14. Are there factors of 14 that multiply to give you 14 and add to give you 8? No. So if it doesn't factor, then what do we have to use? The quadratic. So A equals 2, B equals 8, and C equals 7. A little bit of a pain in the butt, I get it. But I'm going to say negative 8 plus or minus the square root, B squared. So 8 squared minus 4 times 2 times 7 all over 2 times 2, yeah? Did I fill that in correctly? Yeah? Okay, so let's simplify. Negative 8 plus or minus, what's 8 squared? Okay, minus 4 times 2 is 8 times 7 is 56 all over 4, okay? Keep simplifying. Negative 8 plus or minus, what's 64 minus 6? 8, so square root of 8 over 4. Don't cancel anything yet. Don't simplify yet. We got to break everything down. Can I break down 8? So negative 8 plus or minus 2 root 2 over 4. And then now we can simplify. How do we simplify this, guys? If you're going to simplify, you have to simplify everything in the top with everything in the bottom. Meaning, if I were you, I'd split it up. I'd write negative 8 over 4 plus or minus 2 root 2 over 4. What is negative 8 divided by 4? Negative 2 plus or minus, what happens here? So it becomes like this. You can't just cross this out and make this a negative 2. Those two things aren't the same thing. All right? Be careful with that. Be careful. That's not mathematically correct. If you're going to simplify and you have one term in the denominator and one term in the numerator that's split with a plus or minus, you have to put each thing over its own denominator. So this is the same as that. In yellow, not the white one. You're not allowed to do that. Can't do that. Don't do that. We'll talk more about the simplifying. That's algebra. We'll talk more about that as we go. So what does this mean? Is this graph going to cross the x-axis? Yes. at these two places. Do we know exactly where that is? No. But that is an actual place that the graph will touch. Because when you have x squared as your exponent, remember I told you the highest exponent tells you how many answers you have. So there's two answers there. They're not pretty. I'm not going to have you graph something like that, but you do have two answers. Does that make sense? So tomorrow, this is the first part. Tomorrow we're going to do a bunch of these. I'm going to do a bunch with you. Let you guys practice them because there's going to be on your quiz. You're going to have one question you have to do all of this stuff for. So I just want you to get in the habit of doing it. You guys with me? All right. I took out a bunch of the other notes because it's pretty much what I already said. So I have these two. These are pictures from WebAssign. You guys don't have these on there. But I want you to understand how the question is asked. If you look here in WebAssign, it says write the quadratic function in standard form. Isn't this already in standard form? What they mean is vertex form. When WebAssign asks for standard form, they mean vertex form. So write down vertex form again. If you guys want to take a picture of this, you can, whatever. I just want to show you how this is asked. What is vertex form? It's f of x equals a times x minus h squared plus k. You will get that memorized, don't worry. What is h and k? It's your x and y of the vertex, right? Can you identify for me right now what the a value is? It's 1. It's the number in front of x squared. So if you want to write over here, a equals 1. Okay, cool. How do you find the h and the k? If you're given this in standard form, how do you find the vertex? What's that little formula? X equals negative b over 2a. Okay? So what is my b? 10. So negative 10 over 2 times a, which is 1. Okay. So negative 10 divided by 2 is what? Negative 5. Perfect. Now what do I do with that? I'm going to plug it in to find y. So y equals negative 5 squared plus 10 times negative 5, right? Plus 29. What's negative 5 squared? Okay, so 25 minus 50 plus 29. What's 25 minus 50? What kind of 25? Negative 25 plus 29. 4. So where is your vertex? At negative 5, positive 4. Can you now write your equation in vertex form? Yes, you have f of x equals, what's your a? 1. If you want to write 1, you can. And then it's x minus, what's the x value? So minus a negative is plus, right? Squared. And then what? Plus 4. Perfect. So this and this are the exact same thing. One's just in standard form and one is in vertex form. Do you guys see the reason they call it vertex form? Because you can clearly see the vertex there and there. Yes, sir.
We wouldn't like simplify if the one was like a 2 or something.
If we'll do one where the a term is not 1, and you would just leave the 2 out in front, or the 7 or whatever it is. Yeah. So then WebAssign's going to ask you more questions. It's going to say, what is the vertex? Did we just find that? Yes, it was what? Negative 5, 4. So you would write negative 5, 4. What's the axis of symmetry? It's x equals negative 5. Good. We need to know that the axis of symmetry is the x part of the vertex. The maximum, minimum in the range is the y. And then the x-intercepts. Well, given the equation, how do you find the x-intercepts? Is it plus 29? Yeah. How do you find the x-intercepts here? Plug in 0, 4. Okay. And we hope and pray this does what? Factor. Are there factors of 29 that are going to multiply to 29 and give me 10? No. You guys don't have to do this. Just follow along with me. So watch what happens here. I have negative b plus or minus the square root of b squared minus 4 times a is 1 times c is 29 all over 2 times 1. You guys with me? Okay. Negative 10 plus minus 100. What's 29 times 4? What's 30 times 4? 120. So what's 29 times 4?
116.
Okay. So I have negative 10 plus or minus the square root of negative 16 over 2. What's wrong there? It's a negative. Can you take the square root of a negative number and get a real answer? No. As soon as you have a negative underneath, you say, wait a second, that's going to be imaginary. We haven't learned that. That's 2.4. But I know that there's not a real answer to this. So what is that telling you as far as the graph is concerned? It doesn't touch what axis? The x. If you get an imaginary, if you get a negative number underneath your radical, that means there's no real x that it's going to cross. So it says in the directions, if it does not exist, put in D, N, E. That means does not exist. So if you were looking at a graph, which two graphs right away, you know for sure are not the answer? Bottom left and top right, because both of those touch. And then you're like, okay, well, which graph is it? Well, where's the vertex? Where's negative 5, 4? Is it the one on the top left, or is negative 5, 4 the one on the bottom right? There you go. There's your graph. So you don't have to make table of values and all this stuff to do parabolas anymore. You can use all of the characteristics that we're going to talk about in the next 2 days, and you can then figure out what the graph would look like if you had to pick one or something like that. Just wanted to show you guys that. All right, what we want to go over, this is just how to find the vertex. I already did it. You're going to be given questions like this, and this question is answered the same way every single time. It says, given a point, so this is just a random point that's somewhere on your parabola, and the vertex. So let's talk about the letters that they gave us. They gave me a random x and y value, right? Random x, random y. What did they give me when they gave me the vertex? What two letters? H and k. So they are asking us to write the equation of this parabola in vertex form. So let's fill in, this is our vertex form, let's fill in what we have. Instead of f of x, what's that a fancy way of saying? Y. So we put 3. Do I know the a value? No. Okay. Did they give me a random x to use? Yep. Minus, did they give me an h? Yep. Did they give me a k? So every single time you guys are given a point on a parabola and the vertex, what letter are you finding? A. Every time you do the same thing. And now we just simplify. Work on your parentheses first. What's negative 7 minus 4? So I have negative 11 squared minus 1. What's negative 11 squared? So 121a minus 1. Now what? I'm going to add 1. Good. Same algebra, guys, that you've done a million times. So I have 4 equals 121a, and then what? Divide by 4, okay? So your a value is 4 over 121. And your vertex, they told us, was what? 4, negative 1. So now do you have the information to write? It's like when you guys were writing in y equals mx plus b, they gave you a point and a slope, and then you had to plug it in and move around. Same thing. Do you have the information you need to write your equation in vertex form?
Why'd you divide by 4?
I don't know. I meant to divide by 121. I'm sorry. Thank you. Ay, ay, ay. Did I have it written right up here? Yeah. In my mind, I said it right. But do I have the information I need? Yes. F of x equals, what's my a term? 4 over 121 times x minus, what's the x part of my vertex? 4 squared, and then what's the y part? Minus 1. So there we are in vertex form. So again, there's a WebAssign question that says, write the standard form of the quadratic, blah, 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 blah. They don't mean standard form. What do they really mean? They gave me one piece that I need. Label it, guys, so you don't make a mistake. This is H, this is K, this is X, this is Y. What are we going to find first? The A. All right, so instead of y, I'm putting 2. I don't know what a is. Instead of x, I'm putting -3. What am I putting in for h? Okay, negative, right? So minus the negative is going to give me good, koi, +5. And then what's my k? -3. Now we just work inside out. What is -3 plus 5? 2, and 2 squared is? So I have 2 equals 4a minus 3. Now what? Add 3. So 5 equals 4a. What's a equal? 5 over 4. And your vertex is at -5, -3. So write the equation in standard form or vertex form. It's f of x equals, what's my a term? 5 over 4 times x minus a negative gives me +5 squared. And then I have what? There you go. There's your vertex form. Now, if you were asked, I'm not asking you this, but if on a test or a quiz it said, okay, now that you're in vertex form, write it in standard form. So it's like this, ax squared plus bx plus c. You just use algebra. What would we do? We'd say, okay, I have 5/4. You don't have to do this right now. I'm just showing you. X plus 5 times x plus 5 minus 3. So what would you do first? You FOIL this. Then do what with the 5/4? Distribute it, and then what? Subtract what? 3. Just doing algebra. That's it. But 90% of the time, they're not going to ask you to do that. They're going to either say, hey, find the vertex, put it in standard form, or if you're in this form, go to the other one. But the 2 questions on WebAssign that I did on here, make sure you watch. Your WebAssign's not due until Friday, I think. But tomorrow, we're just going to do a bunch of these problems just to practice. To kind of get the hang of it, and then we'll move on. Sound good?